Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about although volumetric flow methods are commonly used in industry, it is sometimes required to measure mass flow, either by compensating for pressure, temperature or density, or by taking advantage of measurable characteristics of the mass with basic direct measurement systems, which are thermal, angular momentum, and Coriolis instruments. Mass flow methods operating with density-compensated volumetric methods are based on transmitting the density or its equivalent from the measurements of temperature and pressure of the fluid to the volumetric method and making simple calculations to obtain the mass flow. In the case of the liquids, if a density transmitter that measures temperature is installed, it will be enough to apply its output directly to the output of the flow transmitter to obtain the corrected flow. The differential pressure signal PA minus PC captured by the corresponding transmitter must be multiplied by the signal from the density transmitter, which is carried out in the compensator. The measuring range of the density transmitter is set so that the correction factor is 1 when the transmitted density corresponds to that of the calculation. If the density transmitter is in a standard condition, the output signal must be manually or automatically corrected for temperature variations in the line prior to input to the processor. In gases, the simple formula is equal to that of liquids because the expansion factor can be included in the K. Various systems can be used in electronic instruments. A compensating unit multiplier-divider that works with a differential pressure transmitter, a PPI absolute pressure transmitter of 4 to 20 mA DC, and a TCI temperature transmitter, and that compensates the flow of gas for temperature and pressure variations. You can make manual corrections for a specific gravity and compressibility. It has an accuracy of plus-minus 0.2% of the scale. A calculating unit that compensates gas flow for gas density variations with manual specific gravity corrections. Its characteristics are similar to the previous unit. It has an accuracy of plus-minus 0.15% of the scale. Digital compensation with microprocessor. The calculation of the module factors is done automatically when entering the measurement fields of the flow, pressure, and temperature transmitters. If these are intelligent instruments, the measurement field can be changed if required. And a higher final accuracy is also achieved by having linearization and viscosity compensation. They also have circuit test buttons, simulation of volumetric flow, pressure and temperature, alarms with indication of error codes, circuit calibration, and its programming. In each of these systems, the accuracy depends on the influence of the components used. For example, using an orifice plate placed in a special precast pipe can have an accuracy of plus-minus 0.5%. In this table are the accuracies that can be obtained with the previous sets without including primary elements or the final instruments. That can be receivers, integrators, controllers, etc. Also called Thomas flow meters, they are based on the rising temperature of the fluid as it passes through a hot body, and they consist of a precision electrical power source that provides constant heat to the midpoint of the tube through which the flow circulates. At equidistant points from the heat source, there are resistance probes to measure the temperature. When the fluid is at rest, the temperature is identical in the two probes. And when it circulates, it carries a quantity of heat to the second probe, and the temperature difference that increases progressively occurs in both probes as the flow rate passes. The difference is proportional to the mass that circulates through the tube, according to this equation. The system is connected to a Wheatstone bridge that determines the temperature difference and amplifies it to an output signal of 0 to 5 volts DC in 1 kiloohms of impedance. The signal can be used on instruments that are located up to 300 meters. The accuracy of the primary element is plus-minus 0.1% of full scale. Its repeatability is plus-minus 0.2%, and the time constant from 0.5 to 3 seconds. The measure is suitable for low gas flow rates that vary according to the 0 to 10 cubic centimeters per minute models. To increase the measurable flow, the fluid is diverted with a capillary, and an inserted laminator guarantees the same laminar flow as in the capillary. As the relationship on sections between the laminator and the capillary is known, by measuring the flow at the sensor, the measurement of the total flow is obtained. Thus, measurable flow rates reach 15 liters per minute in gases and 20 kilograms per hour in liquids. There are no obstructions of the fluid because the measuring tube is straight and its internal walls are smooth. This instrument is suitable for the gases in this list. It can also be used in liquids with very low flow rates. And well, this will be all for today's video. Don't forget to give me a like and subscribe. I upload videos every Wednesday in Spanish and every Friday in English. Adios! Oh, and don't forget to share this to your friends. It will be enough to apply